I'm Peter van Keken. I'm a staff scientist at the Department of Terrestrial Magnetism here at Carnegie Institution for Science. I'm interested in subduction zones, in particular the role of water, how it goes into subduction zones and comes out again. We have known for a long time that water is important in generating earthquakes and volcanism, but we've started discovering more details about that. And I can illustrate some of that using these rock samples. This basalt from Hawaii. It also is a type of rock that occurs abundantly on the Earth's ocean floor. It has minerals in it that have a fair bit of water bound in it. When these rocks go down in subduction zone, they, under high pressure and temperature, form different metamorphic rocks, like this blue schist, for example, that still has a relatively large amount of bound water in it. Then when it compresses deeper, goes down to much deeper pressures, it goes into this type of eclogite, and at that time a lot of water is being released. And we now start understanding that this actually is a cause for intermediate depth seismicity, and I can further illustrate that using a sketch on the board. In this case, we're looking at, for example, the west coast of the United States. There's a cascade volcano like Mount St. Helens for scale, or Mount Rainier, because it hasn't blown its top off yet. At the coastline, we know we have an oceanic trench, and that is where the Pacific Ocean floor is subducting below the continent. This subduction causes, for example, the very large earthquakes like the one in Japan that we had. We also know that when this basalt that goes down, so we have basalt on the ocean crust here. This basalt will be compressed to blue schists deeper down. And then this blue schist will change actually into eclogite much deeper down. And the work that we've been doing is to focus in particular on how these processes work and to quantify them. We know that at depth, due to the subduction of the oceanic plate, it will couple with the overlying mantle wedge, and during that time it will create a hole that can't exist, so it gets filled in with hot material. This hot material causes this plate to warm up very rapidly. This actually causes this blue schist to eclogite transition, which approximately looks something like that in many subduction zones. And during this time, you get water released. This water flows into this hot part of the mantle. This is where melting occurs, and this melt eventually makes it into the volcanoes and helps, among others, to build the continental crust as well. One specific thing we discovered in recent years is that water doesn't just go out into the mantle wedge, but actually flows back up from these dehydration reactions, and they cause seismicity that's inside the crust much deeper down. And this is very well documented for Japan, for example. These earthquakes happen at pressures that are larger than can be expected for brittle deformation, and essentially the water helps lubricate and weakens the rock locally, much the same way as earthquakes in Oklahoma are caused by a re-injection of water into the subsurface. That's it.